Now, the final presentation of this event will be given by Helena Wessman, who is working here at VTT as a senior scientist. In Helena's presentation, she will wrap up the solution, also wrap up the event, and talk about eco-efficiency, carbon footprint, and water footprint. So Helena, the booth is yours.
Okay, thank you, Thomas. Yes, now it's time to wrap up. And my focus is more or less in environmental communication, since it seems to be a challenge to the industry. First, it is difficult to find an indicator that is simple, that is easy to understand for customers and consumers, but at the same time the simple indicator has to be science-based, so it has to be reliable. And secondly, it is so that we have so many indicators now available and methodologies to use that the knowledge really causes pain. On the left-hand side, you can see a map of how forestry information, for instance, can be informed. So there are several ways what to choose. But like I said at the third part, the entity matters. So a toolkit of the method should be used and not rely on only one indicator. It's always better to give a wider view on what is the environmental situation or sustainability situation of the company. So here, simplified science-based solution, it has to be based on life cycle thinking. That is usually the basis of all the sustainability indicators. And LCA, life cycle assessment, which is the most commonly known and used tool for life cycle thinking, it's based on inventory. And that inventory means that it's an eco-balance. It means that you have calculated and collected information on the input flows and the output flows, and that's the balance for materials or energy or euros or whatever. And again, the inventory is based on product value chain, so that is the key message also, the value chain. You have to know the value chain of your process, of your product. And value chain usually includes the energy consumption, material consumption, chemicals, raw material use, emissions. And it is a transparent way of telling your inventory, your eco-balances. And here below is the very limited picture actually of fiber products value chain, beginning below from the forest. Then the fiber goes to pulp mill and then to paper mill. It goes to a customer, which is probably a converting plant, and it's situating in another country. You need some transport. Then the product, which is in this sense newspaper, it goes to end user, who, if it's environmentally friendly end user, he will recycle it. It goes to a recycling phase, or it is incinerated, or it just is thrown away, which means that it goes to a landfill. So this kind of value chain information usually is needed for all the processes. Okay, how do you can use the environmental tools then for communication? Usually you can use them in decision making in companies, benchmarking processes and products, when you want to optimize your logistic routes, for educational purposes inside the company, for instance, for market use, and for eco-labeling or product declarations. And then to the indicators. I think the most commonly used of those indicators nowadays is carbon footprint. Carbon footprint tells you about the amount of greenhouse gases that are produced along the value chain. So there's the value chain thinking again. And greenhouse gases, it's not only CO2, it's also other greenhouse gases like methane. And methane, for instance, can be approximately 25 times stronger by effect, environmental effect, than CO2. And carbon footprint tells you about the fossil greenhouse gases. That means that which are coming from when you're using fossil fuels, or energy or electricity which is produced by using fossil fuels, or then the landfill effect. And there is usually methane which is coming from the landfill phase. So that's quite important from the carbon footprint point of view. Inside the red circle there is forest, and it means that also the role of the forest is to take carbon from the atmosphere. But when you use the tree, for instance, you burn it, then it releases its carbon dioxide. Or if you are building a house, so it's like a carbon sink. So the modeling, how to take account this biogenic carbon, as we call it, is still under research. But it belongs to this carbon footprint chain anyhow. Okay, there are other environmental indicators coming. And first I have listed land use. Land use is an indicator we have been working quite a lot in the environmental science world many years. It has become more and more important because there's a limited land resources, but at the same time, for instance, biomass production needs more and more land because we want to eat it, use it as a fuel, or just use the land as an ecosystem service, so for recreational values. Biodiversity is also coming, and it's very important and to realize that the diversity of species is decreasing all the time, quite heavily. But the issue is that we don't have indicators now at the moment to assess the biodiversity. We have some red list species, but it's not enough. We should know what are, for instance, changes in land use, for what species it will affect and to what extent. So that information is missing. Waste footprint is quite practical. It's a good footprint. I like it. It expresses efficient material, recycling and reuse. So that means that if you effectively reuse and recycle, so the more raw materials, for instance, fiber or minerals, will stay, and you don't have to use them so much. And then, of course, social indicators and ethical indicators are always under development, like actually all the indicators. I have said that under development here, social indicators, but that means all the indicators, and that's a good thing because the more information we get, the more we have to develop those indicators all the time. On the right, I have put a picture. That is one approach how to evaluate different environmental parameters like climate change or ocean acidification or biodiversity, and see what is the situation at the moment, what is the capacity of the Earth. So the green circle in the middle means that the certain indicator is, the state is fine. If it goes red, it goes over the capacity of the Earth. So climate change on the top, it says that it has gone already too far, but like you see the biodiversity is on the left-hand side, the big red line there. So that is really the next major issue to solve. Okay, eco-efficiency. That is also, that's my favorite indicator actually. It links environmental and economical issues together. So it's practical and it's, how to say, a company-friendly indicator in sense it links environmental and economic aspects together. It tells you how to create more value from less material use and less impacts. And it's usually used to assess the energy, material and resource use and to evaluate technology. And you can find some information from the net from the World Business Council Sustainable Development pages. They have in a way evaluated some companies and some eco-efficiency indicators. But there is also now a new ISO standard, 14045. So that gives standardized principles how to calculate the eco-efficiency. And I really like to recommend the companies to try it and to use it. We have here at VTT, we have built a framework for water efficiency. And here you can see process framework and what are the factors that belong to the process efficiency calculation. So in the middle it's a production plant. Above comes flows, input flows from, in this case, from cooling water, process water and steam. Steam is also water. And besides, you have to know how much as volume there are coming water in different sources. You have to know the source. If it's public supplied, self-supplied, fresh water, brackish water or whatever. And also the treatment, intake treatment. What comes out below is cooling water, water discharge and evaporated water. And again, you have to know where the water is going. On the left, there is also coming in fuels, materials, chemicals, and that means that you have to take the value chain approach again. You have to know what is there before your production phase. And of course, there are some water coming in along those chemicals probably. Out is also going products and co-products and waste, and there is also some water included in the product, or at least usually in the waste. So this kind of process framework is needed when you start collecting data for the water footprint and also for the water efficiency calculation. And how you put the economic part into this. So there's here are only some examples of what kind of economical data is needed. So for instance, water intake, there is availability, price and sufficiency of water, acquisition costs, treatment costs, and perhaps investment costs. And when we're talking about the products or waste, so there might be some branding issues where you can perhaps evaluate the value. And certainly there is, if there is a water content in product, so that is directly can be calculated as transportation costs. But anyhow, the allocation of indirect water consumption and indirect water-related cost, it is quite challenging, and we are working on it at the moment. And the last bullet point, if you remember in my first slide, was toolkit of methods. So now I have been introducing those footprints to you. They are science-based. They have usually they are most of them are standardized. They are based on value chain, but still they are only a footprint. So the recommendation actually is that do not stay on one footprint. If you are studying your whole value chain, there might be other issues like material use or chemical use that needs some evaluation. So maybe one footprint is not enough. It's recommendable that you should think the whole value chain and also think how, for instance, water and energy, perhaps they are linked together. For instance, in forest industry processes, the less water, the less drying, less pumping. I guess the same is with the mining as well. Less water, less pumping. And how we also, Jani handled this issue quite widely. So chemicals consumption and those are linked to water use as well. But there is also land use and resource use, waste management, which are linked to each other. So that kind of sustainability evaluation is the future. And this is my last slide. This is just presenting how in VTT our sustainability group is working with this sustainability question. So on the upper level, the sustainability assessment for new products or new technologies. And then we make life cycle assessment and critical reviews, and then develop sustainability indicators for certain industrial sectors. So this is more or less research project work, bigger projects that we are working with these issues. Then in the middle, there are those tools that we quite often and regularly use, eco-efficiency, carbon footprint and water footprint, and also we have LCA software which we use to calculate these results. And some specific questions might come for eco-design, environmental product declaration perhaps, or then a flow analysis for material and energy. So that is also something we are working with. Yes, that was all. Thank you.